Hi again, everybody, and this is Joseph with a continuing tutorial. As I have been explaining and stressing the point of the proper meters to use, especially for automotive, I already made a video about the fluke meter, which is the best for this profession. This is the fluke, as you can see. This is the 83, and they upgraded it to 87 and others. And this is basically what you need. So first we always have to understand the functions and where to put the probes and all these things. So let's go over the fundamentals, the basics. As you can see, first of all, this jack, which is the red, notified by the red input over here, gives you three things that you can measure. Volts. It doesn't matter AC volts, DC volts, ohms and continuity, and a beep where you can beep it, and also a diode test, which you have over here. Now, the black always stays common. You don't move the black. So the other thing is, as you can see, hopefully you can see, there is a certain amount that you can do 1,000 volts in this, that it's permitted to use until that limit, as you can see over here. Other thing we have to notice, when we measure current, we usually open up the circuit and we will put this probe into this, noted by red. Red means we shift the red. See? We shift the red. Well, if we're measuring 400 milliamps, up to 400 milliamps is fused. Let's say I'm measuring 100 milliamps in the circuit. I can take this one and move it over here into this one. Or microamps, which is even smaller, as you denoted by here. Now, if I want to measure something much larger, let's say I want to measure 5 amps. I have a lighting circuit in automotive which takes 5 amps. Sometimes they take 12 amps, 15 amps. But let's say I know it takes 2 amps. I will put this one, not over here, it's too small. I will put it over here. And I am safe until 10 amps. I'm fused. That means I'm safe. There's a fuse internally in the meter until 10 amps. If I measure 15 amps, it'll blow the fuse. If I need to measure 400 milliamps, and I measure 800 milliamps, it'll blow the fuse. So you're better off putting it always on the safe side, putting it on this side. So let's start. As I explained before, many functions. This is different from the other one, the digital meter, multimeter. That this is auto range, as I've explained. In other words, it'll automatically calibrate the proper scale with the proper digits to give you the measurement that you need. You do not have, there is no increments here or ranges. In other words, you don't have 20 volts, 200 volts, 2,000 volts, 0.2 volts. It's automatic, auto range. And that's the beauty of this, and that's what you need. This sign always denotes a sine wave. A sine wave is an RMS, and I made a video about that. And please subscribe to my channel of Automotive Electronic Schematics by Joseph. You have many videos. AC means I'm measuring RMS, which is the outlet of your house voltage. AC volts, RMS, root mean square. So therefore, if I want to measure AC, well, let's say I want to see my outlet. I'm not sure if I have voltage coming out of an outlet. I would put it in this one, and I'll show you. I want to measure a battery. I want to measure the car battery. Denoted by this straight line means it is constant. DC volts is constant. It's DC volts, and it does not alternate. As opposed to AC volts, it alternates. How many times a second? Depends on the frequency. Millivolts is smaller, is 1,000th of a volt of this, and this is DC volts. As we stressed over here, ohms. If I want to measure resistance, like we will, the simplest thing, a fuse in a car, I want to know if it's blown. And to repeat, you cannot look at just a fuse and say it's good or bad. You have to measure things. That's the most accurate way. So therefore, in this position over here, I can measure ohms. If I don't want to look at the meter, I could put it on the beep. And therefore, I don't have to look at the meter constantly. I could just listen for the beep and to know that something is connected. This is a diode test. In the olden days, for alternators, we used to use this. Today, everything is computerized in the alternator. It tracks or controls the field windings in the alternator to give you the proper current based from the regulator, based from the PCM, based on the loads that you have. So everything is computerized in the alternator. Now, other thing is that we said the milliamps and the microamps is this is DC or AC. Like I said, you have to open up the circuit. You have to, if you have a circuit here, you have to take out a component or a wire and put this in series. You usually do that with the battery when you put in series. Now, to get to the point, first thing is always you have to make sure that the cables are intact. And as you see over here, I have plenty of this I added, an alligator clip. This is a strong grip alligator, as you can see. Look at the teeth. These are strong. I have another one, which is even stronger. These are strong grips. They will not let go. Different colors, whatever. There's many type of them. First thing is, always make sure the cables work, your probes work. How do you do that? You put on the ohms. Because if these do not work, and I'm measuring sensors, mass airflow sensors, TPS sensors, intake air temperature sensors, and my probes are not working correctly, I will get inaccurate measurements. I'm going to be chasing a problem that I think is a problem related to a bad sensor when the probes are not good. Why would you spend so many hours doing that or minutes doing that when your customers are complaining? Do the first test, the basics. The basics. You connect them together and you have 0.2 ohms. That's great. You want to see something like 0.2 ohms, 0.3 ohms. You don't want to see 1 ohm over 1 ohm. It's too much. Therefore, you see how good it is? It's a good grip. These type of connectors. I always use these. Again, you can put it to the chassis, to the metal frame, to a bolt on the automotive, to the negative, wherever you want, whatever is metal. Now, we want to measure 120 volts AC. Where are we going to put it? Proper range, not millivolts, that's DC. That's DC. That's AC. Remember, we leave these probes as connected because we have 3 options: ohms, volts, and diode. We're going to measure volts. As we said, doesn't matter AC volts, doesn't matter DC volts. Now, in order to do that, I have to take this out. Now, connect it. AC. As you can see, 121 volts AC. Let me put this on. AC volts. There's a range over here. I don't know if you can see it. That gives you a range up to 400 now. If you want to look at the analog. Digital display over here tells you it'll be 100, 200, 300. You're over 100 and you're in between 200. We don't need that. This is auto range. You see? As soon as you put it, it gives you the proper decimals. It could give you 122 volts, and that's good. But it gives you the proper 122.1. Now, as I stressed before, you have some. Look at these functions over here: minimum, maximum. Now, minimum. If you press it again, maximum. And you get something called average. So, let's say I put it into my outlet and it's fluctuating. 121, 122, 122.3. I press this minimum, maximum, and average. It'll give me the average. So the average from this outlet is 122.1, which is good. I want to measure the hertz. Remember we spoke about the frequency? Here's the hertz. Almost 60. So good, we're happy with that. Notice the display it gives you, 59.99. Auto range. It can give you 59.9. I can set that manually, which range to give me. But in auto range, it gives me the proper decimal points as much as I need. And that's sufficient for me. 59.98 is rounded off to 60 hertz. This is hertz. Okay? Now, let's measure a bad battery. So, let's take this out. And it's very good practice. Very good practice. Every time you do it, again, put it on ohms. Put it on ohms. Every time you do it, here, let's see. Make sure the leads work every time I change the range. Again, we're going to let's measure this. As I said, we're going to take this, make things much simpler, so we're free with one hand. Okay? Again, every time we change the probes, every single time, let's make sure. Because if this is fluctuating, 1 ohm, 2 ohms, my measurements will be off. Especially when I measure voltages. So therefore, connect the probes together. And now here's a function we said. Now, as I specified before, it gives you the beeps. What's the function of that? If I'm measuring, let's say in auto, and I'm looking for a ground, and I want to measure for continuity, see what's connected to the negative. The negative goes to the engine block, and then it goes to the chassis, then it goes to the bolts, to the metal frame. Well, I want to measure continuity. I don't want to look at the meter. So what do? I put this on beep, and I automatically don't have to look at the meter. I just listen for the audio response, so to say. Okay? That's a great tool to have. Most of them have them, but for sure the Fluke has all these features, as you can see. Now, let's measure a simple fuse. Like I said before, do not be getting into habits. Well, I can see the fuse is good. Some of them have thinner elements inside. Do not be mistaken by that. You have a meter. The most accurate way to measure something is through a meter. Remember that. Otherwise, you will run into mistakes. Now, I want to put in one probe to hold it. I want to put in the other one. See how it beeps? Okay. I don't even have to look at the meter. Another thing to point out that I wanted to point out, when you measure resistance, like I said in a specific video, you do not put your both hands across the resistance that you're measuring. What's the reason? Your body has resistance. It may be in the kilo ohms or whatever. As you have obviously more, if you're wet, your resistance goes down. Therefore, you have more in a hazard to conduct more current if you're measuring voltage. We're not measuring voltage, we're measuring ohms. But what I'm saying is, when you have resistance in your body, and I'm going like this, and I'm measuring across something that's high resistance, this is low resistance, it won't be affected. But if I'm measuring with two hands across something, my resistance is in parallel or across the component that I'm measuring, and it'll change the resistance. I'm talking about resistors, high values, kilo ohms, mega ohms. I'm not talking about low ohms like this. So keep that in mind. As you see, the practice is one hand I put an alligator clip, and the other one I go over here. Always. Okay? That's how you measure things. Again, fuses, low ohms, 0.3 acceptable. Okay? If this would be open, I would be measuring this at a limit, at a range. So therefore, remember, when I'm in the car and I'm measuring, I would be measuring from here to here. From here to here I would be measuring, because it's in the fuse. I took it out to just show you for demonstration purposes. Okay? We want to measure a DC battery. Any battery, doesn't matter. What's the proper one? Again, I'm trying to... Okay? Correct scale, DC volts. Let's measure a bad battery, whatever. Okay? What do? We can leave this in, this probe, or we can take it out. Doesn't matter. We all know the positive associated with this. What happens if I change the probes on the battery in automotive? First, let's do this. Do this. That's why I like having alligator clips. Actually, it's a good battery. 1.6 volts DC. What would happen if I go to measure the car battery, which is 12 volts? And you know what? I mixed up the probes. So, the probes I mixed up. This is the positive, and I'm putting the negative. And I'm putting this one. Notice you get a negative sign. When I get a negative sign, that means my probes are the opposite. You still measure voltage, but you're measuring negative now. Negative polarity. That means you flip over the probes. In other words, I should put positive here, I should put the negative here. But sometimes you do measure, with respect to ground, a measurement, a voltage measurement that is negative. Negative 16, negative 12, which is proper. You have to look at the schematic and figure these things out. So therefore, again, I want to reiterate many times, this is the standard of automotive. If you want to do automotive, these type of meters are the best to use. And I highly recommend it. I hope this was very informative. And I hope that you subscribe to my channel on Automotive Electronic Schematics by Joseph. You'll find many schematics, and like I said, for scanner tools, to understand the measurements and to understand the check engine light codes that you have. When it says oxygen sensor measurement rich or lean, you have definitions over there. It is not seen ever on YouTube. There is no information about that. I am the one that has the manuals for that, dealership manuals for things like that. So therefore, please look at those videos. I am so happy that subscribes are going up. Thanks to my viewers, and please leave comments. Always welcome. Thank you for watching.